These days we hear a lot about energy sustainability, especially with the conventional energy resources like fossil fuels running out quickly. More and more people are realizing the importance of renewable energy resources. What are those and how can we get them? Well, there's abundant energy in the environment for us to use. Examples are heat, motion, and light. We cook, we keep our homes warm, we generate heat. We walk, we drive, there are tons of different vibrations in the environment as a source of mechanical energy. And obviously we have access to light. Challenge is converting all these ambient energies into electricity that can power our devices for us. Luckily, we are at the point in time that technology has enabled us to have low-power devices in milliwatts and microwatts range. So what are the emerging applications? There's a huge potential for the application of wireless sensor networks, a group of low-power sensing devices that normally consume less than a few milliwatts in a wide range of industrial sectors like defense, transportation, healthcare, and manufacturing. At the moment, they are powered using batteries. Batteries have a short lifetime, they're costly to maintain, and they have recycling issues. So energy harvesting technologies offering a solution to be able to power these devices in an environmentally friendly way. So what sort of energy harvesting technologies are available at the moment? Mainly 4 different types. First one, based on the conversion of mechanical energy into electrical energy using piezoelectric and electromagnetic materials. The second type, based on conversion of heat or thermal energy into electricity using thermoelectric materials or pyroelectrics. The third type is based on photovoltaics or solar cells that convert solar energy into electricity. And the fourth type relies on the conversion of radio frequency into electricity. Piezoelectric materials convert mechanical energy into electrical energy and vice versa. What is the origin of piezoelectricity? Well, under mechanical deformation, there's a rearrangement of atoms within a piezoelectric crystal that induces electric charge in the material that we can harvest afterwards to power our devices with. Where are the piezoelectric materials? Are there any in daily life around us? They are actually everywhere. In a watch, there's a quartz crystal that is a piezoelectric material that deforms periodically, and that generates electricity that keeps the time. In headphones, there's a piezoelectric material in the loudspeaker. When the electric signal gets to that membrane, it deforms and that generates acoustic waves that we can hear. In inkjet printers, there are small piezoelectric elements in the cartridge. When the electric signal gets to that element, it deforms and that opens up a nozzle that deposits ink. Here in Bath, we work on flexible piezoelectric materials. Conventionally, there are 2 types of piezoelectric materials, ceramics and polymers. Ceramics are very good piezoelectric materials, but they're hard, brittle, and difficult to shape and very difficult to integrate within different devices. Polymers, on the other hand, have lower sensitivity and lower thermal properties, but they are flexible. So the idea is to combine the best properties of these 2 classes of materials within a composite structure where the ceramic is functional and the polymer is there in order to provide flexibility. Here we have an example of a fiber-based piezoelectric material attached to a bar that we are going to vibrate, and that material turns mechanical vibrations into electricity that is going to run the temperature sensor for us. We generated enough electricity to run a temperature sensor. There are many more applications around us, so energy harvesting technology is providing us with battery-free solutions.